Introduction to LEO Broadband. Low Earth Orbit, LEO, satellite broadband is a new and exciting technology that has the potential to revolutionize internet access for people living in remote or underserved areas. Unlike traditional satellite internet, which relies on geostationary satellites that orbit the Earth at a distance of around 36,000 kilometers, LEO satellites orbit at a much lower altitude of around 1,200 kilometers. This closer proximity to the Earth means that LEO satellites can provide faster and more reliable internet connections with lower latency. One of the main advantages of LEO satellite broadband is that it can cover large geographical areas with relatively few satellites. Traditional satellite internet systems require a large number of satellites to provide coverage, but LEO satellites can cover a much larger area with just a few dozen satellites. This makes LEO satellite broadband a cost-effective solution for providing internet access in remote or underserved areas. Another advantage of LEO satellite broadband is that it can provide internet access to moving vehicles such as cars, buses, and trains. This makes it an ideal solution for providing internet access in areas with a high mobility such as ships and aircrafts. The key components of a LEO satellite broadband network include satellites, ground stations, gateways, antennas, network management systems, and specialized software. The satellites are responsible for transmitting and receiving data to and from users on the ground. They orbit at an altitude of around 1,200 kilometers and use advanced modulation techniques such as multiple input multiple output, MIMO, to increase the capacity of the signal and reduce the impact of atmospheric effects on the signal. Grounded facilities, called ground stations, are responsible for communicating with the satellites and routing data to and from users. These stations can be located on the ground or on aircrafts, ships or vehicles. Gateways are the connection points between the ground stations and the internet and are responsible for routing data to and from the satellites and the ground stations. Antennas are the devices that users on the ground use to communicate with the satellites and can be installed on homes, businesses, or vehicles. The network management systems are responsible for managing and monitoring the network, including routing data, allocating bandwidth, and managing security. Specialized software is used to control and manage the network, schedule satellite communications, and manage security. However, LEO satellite broadband is still a relatively new technology, and there are a few challenges that need to be addressed. One of the main challenges is the need for a large number of satellites to provide adequate coverage. This requires significant investment in satellite manufacturing and launch capabilities. Additionally, LEO satellites have a shorter lifespan than traditional geostationary satellites, which means that they will need to be replaced more frequently. The future of LEO satellite broadband is promising, with many companies investing in the technology, and a growing number of launches planned. Advancements in technology such as the use of smaller, more efficient satellites, and the development of new manufacturing and launch capabilities will help to reduce costs and improve performance. In conclusion, LEO satellite broadband has the potential to revolutionize internet access in remote and underserved areas. With a growing number of companies investing in LEO satellite broadband networks, it is likely that we will see more widespread adoption of this technology in the near future. This new technology has the potential to bridge the digital divide, providing internet access to communities that were previously unconnected, and also to provide internet access in areas with high mobility such as ships, aircrafts and trains.